Hello children, welcome to channel Sube. Children, today I am going to discuss question number 36 from the MCQ part of 2021 Physics New Syllabus paper. An equilateral triangle is constructed using three rods having same cross-sectional area as shown in the figure. All the rods are perfectly legged. Thermal conductivity of the material of AB is twice that of AB. AB is this one. AB is twice that of the materials AC and CB. AC and CB. So that means the K values are same here. So here 2 times. That is the meaning of this sentence. Material AB and materials AC and CB. Ends A and B are maintained at 100 centigrade and 0 centigrade. So this one 100, this one 0. That is what is respectively. At the steady state, the ratio rate of heat flow through AB is this one. Divided by rate of heat flow through AC. AC is this one. That ratio is what we have to find out. So children, let us try to solve this. When we come from this end to this end along this rod, the temperature rise is 100 centigrade, from 0 to 100 centigrade. The same way, if we come along this path, the temperatures are initially at this right side, the temperature is centigrade 0, here centigrade 100 centigrade. So there is a 100 centigrade rise. The temperature increase 100 centigrades when you come along this path. So since these rods are equal, because they have same K, they have same area, cross-sectional area. So that is mentioned in the question, cross-sectional area same, and also same length. This one also has same length, has same cross-sectional area. Only the K value, means the thermal conductivity, is twice regarding this one. So regarding these rods, everything is equal. So therefore we can consider not as two rods, we can consider these two as a single rod. So this point is the middle point of this single rod. So therefore the temperature must be the middle point of this range. So that means that must be therefore 50. The set temperature at this point must be 50. So using argument you can decide that the temperature is 50 centigrade. So children, since this is the short method, I don't write all the equations using everything I do in my head. So you also have to do the same thing without writing much. You have to do all things in your head. But after doing this, I will show you writing all these equations and go into the answer. So let us, what we have to find out is rate of heat flow. That means dq divided by dt. So of AB divided by that of AC. So the equation is what? Equals Ka theta 2 minus theta 1 divided by L, this L or D. Sometimes we say D. Here we have taken the length as L. So at the numerator we get AB first. AB first means this side first. That means 2K we get instead of K. That is in the equation. In the equation there is a K. So there here it is 2K. So temperature difference 100. Cross-sectional area cancel. Divide by here to this one. Then K. K temperature difference is 50. That's all you have to write. Then K cancel. 200 divided by 50 is 4 times. The answer is 4. So this one is the answer, the fifth one. So question number 36, let us check it. 36, 35, 36, the fifth one is the answer, correct. So that is how we have to do it. So children, I know the way I explained this, discussed this problem, everybody can't understand. There are students who can't understand really this way. So therefore I am going to explain in detail now. So children, first of all I will show you, I decided the temperature at this junction is 50 centigrade. So if you can't understand that, I will explain it. So first of all you should know there are two lines. Two lines means two paths. So this one is the first path, this one is the other path. There are two paths to come from the given temperatures 0 centigrade to 100 centigrades. So these places are at constant temperatures. So this one is at higher temperature. So you know heat flows from higher temperature to the lower temperature. So some heat flows along this rod like this, and some heat flows along this rod and transfer into this rod and along this path to this lower temperature. So like that. So that is why I said there are two paths. So this ACB path, consider this one, this path. So it has the same, the rods has, the material has the same K value. K value means the thermal conductivity, and also same area, cross-sectional area, these two, and also same length. So since these both materials have same K, we can imagine, we can suppose that is actually really the same material. If this one is iron, this one also iron. If this one is copper, this one is also copper. Therefore no difference. So we can therefore take this these two rods not as two, just as one. We can imagine that these two rods as a single rod. So we can erect them now without considering this bend. So like this we can erect it. So there is no bend now. We can erect this these two rods, but actually we are thinking that these rods are not, there are no two rods, only there are one rod. So like this, not like this, not like this, just one rod like this. So I have to use same color like this. So this midpoint is this one, C. This one is the place where they have denoted as C. So this place is B. So I have erected this one. So this one A. So the temperature here is 100. So the temperature here is 0. That they have given. But here the temperature they have not given. So let us take as theta. So the length is L. This one also has a length L. So cross-sectional area is also equal, and the K value also equal. So everything equal. So now we can focus our mind to at the steady state. What is that? Steady state means you know, in practice, when we do practicals in the laboratory, we fix thermometers in these places like this. Thermometers we fix like this. Anywhere you can fix a thermometer to get the temperature reading. So steady state means if the temperature doesn't change, rise or fall, if the temperature doesn't change, then with the time, from time to time we have to take the readings, and after a certain time we can decide these temperatures are constant, they are not changing. So after 5 minutes we can decide that from minute to minute we have to take the reading, observe properly, then we can identify that these thermometers their reading they don't change. So at that time we call steady state. So what is steady state is then? So children, what is steady state? So that is when the temperature has achieved reached a constant state. When the temperature reached a constant state, we call that state is steady state. So to identify that, from time to time we have to observe the thermometers. So that is how we do it. So children, now let us write equations for this one. At this steady state, what we can say, why these the thermometers get a constant reading? Why the temperature become constant? The temperature becomes constant because so still we are talking about this steady state. The temperature becomes constant. Why? So imagine that there is a thermometer like this. So the temperature previously was increasing like this. So we observed that previously a minute ago the temperature was 60, after a minute now it is 61. So like that temperature is increasing, we can identify that. So after a certain time we observe that the temperature doesn't change. Say at 70 it is always 70, after 5 minutes even it is still 70. So that is the steady state. So why that happen? What is the reason to not change the temperature? So that means children, so still we are heating this side. To keep this temperature at 100, we have to heat up this side using a flame or some source. So now the temperature at this point is constant. That is the steady state. So this is how that should be described. So the dq divided by dt is what? The rate of heat flow. Let us just write q divided by t. What is this q? Heat energy. What is this time? T, it is time. So that means heat energy flow per second. So this q divided by t term here, that is incoming heat. So it is equal to the q divided by t term leaving this place, that is the heat leaving. So the heat incoming is equal to the heat leaving. So therefore the temperature can't rise up or fall down. So it stays constant. Therefore, if the amount of heat coming in is too much and leaving is little less, so what happens? The temperature rises up like this. So if the temperature, if the heat coming in is very little and leaving is higher like this, lot of heat is leaving like this, say, assume, then what happens? The temperature decreases like this. So that is the mechanism of this steady state. So if the steady state has reached, we can therefore write that q divided by t equals to the q divided by t for this rod and this one for this rod. At this junction, the heat coming in is equal to the rate of heat coming in to this junction is equal to the rate of heat leaving this junction. So that is the principle. So therefore children, now we can write this equation as I explained, Q divided by T for this rod AC, so like this rod AC, and Q divided by T for this rod CB. So we can equate these terms. So you know Q divided by T is equal to, in the lesson we know that this equation. In the lesson we learn that Q divided by T is equal to this one. So let us keep it aside like this somewhere here. So if you have forgotten now, you must remember this equation. So let us therefore we can equate right side. If the left sides are equal to each other, we can equate the right sides too, like this. For these two rods, we equate for these two rods. So for the first rods, let us substitute the values. What is K? K is same K, and also for this one also K. So we can write K. We don't have to change. So area now, area also A and A both same. So we don't have to change this one also. So D, instead of D we have to write L. So because we have taken L in the equation, even though it is written as D, so we have to write it as L. This L won't work. Let us write it like this. Delete this one, because in the equation it is denoted by D, but here in the diagram we have written L. So L. So now we have to write the temperatures. So the temperature T2 is the higher temperature for this rod. So we are writing for this rod 100. The temperature is 100. Here you see it is 100. So we write therefore 100 here. And the temperature for this rod, the temperature at the end of the rod, end of this rod, what is this one? Theta. So end of this rod is this one, theta. So let us write therefore theta. The lower voltage is theta. Now here for the second rod, but we are thinking it as a one rod. So let us write this equation. So here in this rod there are two ends. So the first end has the temperature theta. So let us write theta. That is the higher temperature. So the lower temperature is this one. So we write 0. Now we have to simplify this. Let us cancel whatever possible. So L cancel, K cancel, A cancel, everything is other than 100 and theta. So here 100 minus theta equals here only theta. Theta minus 0 is theta. So when we take this one here, we get 2 theta. 2 times theta equals 100. So then theta equals how much? 50. 100 divided by 2. So all these things you have to do in your head, and you should be able to decide that the temperature at this point is 50 as the way I did previously. So that is it. In detail, if I explained it, that is how I decided that the temperature is 50 here, because I did all these cancellation in my head. Only I decided this, only I calculated this thing, that also inside the head, not on the paper. So children, now there is no doubt about that part. Let us now go to the question. I described only how to decide the temperature at this junction C. So it is over now. So let us talk about this problem now. What we have to find out is the rate of heat flow through AB divided by AC. So that is why we need. So let us take it here. This is the real question we have. So this one is what they want us to find out. So what is the rate of heat flow means Q divided by T. Q divided by T for the rod AB, and the total thing divided by Q divided by again T, that is the rate of heat flow. The Q is heat, when we divide it by T, that is the rate. So this is what we have to actually find out. This is what we have to find out. So we know the equation. Again we use this equation, but we equated it here. Here what we have to do, we have to divide it, because what they want is this ratio. So we write this one, that is for AB, the rod AB. Rod AB is this one, and then we divide this thing by this term. This term is what? For rod AC. AC is this one. So AC. So this is what we have to do it. Not a difficult thing. So instead of dividing, we can multiply this, but we have to invert these terms. This one goes down, this one goes up. So like this. Very simple. So everybody can understand, even though you haven't learned this lesson even. So here now let us substitute these values. So what we are going to do to find out this term? So instead of D, we know that we have taken L. So let us write L. So both the rods have the same length L. Here L, here L. So we don't want this part now. Let us delete it. We don't want that, because what they are asking is only the ratio of this part and this part. So now let us substitute the values. So this one is for AB. Still we need that letters AB. This one is for AC. So for AB is this one. What is the constant? That is 2 times K. They have given it. They had given it in the previous, so I had deleted it. Oh, I think I hadn't marked it. So now let us mark it here. 2 times K they have given it. So here it is K. Here it is 2 times K. So let us substitute it for this part. So 2 times K, 2 additionally we have to add to this one, 2 times K. So both the rods have same cross-sectional areas. Therefore A, here A and also here A. Then L same, then theta 2 minus theta 1. That is the temperatures at both ends of AB rod. AB rod is this one, 100 minus 0. 100 minus 0. That is the temperatures. And for AC rod, what are the temperatures? For AC rod, so this one is the AC. Temperatures. First one 100, that is common for both the rods. Here we know 50. Then 100 minus 50. So let us substitute it here. 100 minus 50. That's all you have to do. Now let us delete these unnecessary things. We have finished substituting. Right. Now let us cancel whatever possible and simplify, then we get the answer. So L cancel here, and K also cancel, A also cancel. Then what is remaining? 2 times 100 minus 0 is 100. Then times here nothing, therefore we don't have to write that. Then divide by 100 minus 50 is 50. Then what is the answer? 200 divided by 50. So the answer is 4. Answer is 4. So that is why we choose this one as the correct answer. So I think now everybody can understand. Fifth one is the answer. So children, I think you are happy, you can understand. I solved the problem in both ways, rapid way and slow way. This one is having more details, so like this. So let us wind up this. So now I am going to do a sort of target question. Children, here I have designed a target question for you. So let us try to do this. So the question is this one. So I have changed the temperature here from 100 to 120, and there are 4 legs now, 4 rods. The previous one had only 3 rods, it was a triangle. So here this one is a square, equilateral square is constructed using 4 rods having same cross-sectional area as shown in the figure. All the rods are perfectly legged. Thermal conductivity of the material of AB is twice that of the materials AC and CD and DB. Ends A and B are maintained at 120 centigrade and 0 centigrade respectively. At the steady state, the ratio rate of heat flow through AB divided by rate of heat flow through AC is equal to, there are 5 answers. So you try it after pausing the video, pause the video and you can try it. In 2 minutes you should find the answer. So after that I will show you how to solve it. So now children, I think you have found the answer. So I will show you how to do it in short method using the same equation. So I don't write all these things, this equation, I don't write these denominators because they cancel each other. You see here and here cancel each other, and I don't write this cross-sectional area, they also cancel. I take only K values and temperature difference. So let us do it now. So at the numerator they have written AB, so we have to write first this one. So the numerator of the ratio, so the temperature difference first 120, temperature difference 120. So the K values, if this one is K, they have given this one is 2 times K. I didn't change much, just a little details I changed like this. I didn't change this K values, so I took it as same as previous, so K and 2K. So here we have to write 2K because we are writing to this rod. So and also we are writing this numerator and divide by the numerator of this one, this rod. So here we have to write K and the temperature difference. What is the temperature difference between these two ends? So it was easier here, 120 and 0, just we had to subtract and get the value 120. So the same way as we did in the previous problem, the K values are same here and here and here. K values are same. Also cross-sectional areas are same, and also lengths are also same. Therefore we can divide this. Before that I have to say, even though you followed this path, you start at 0 and you finish at 120. So the total path is divided into 3, 1 and this one and this one and this one, divided into 3. Therefore temperature differences should be same. that means 120 divided by 3. What is the value? 40. So that means the temperature difference here is 40. Here another 40. Here another 40. So altogether 120 is okay. 40, 40, 40. So the temperature here 0. Here the temperature is 40 centigrade. Here the temperature is 80 centigrade. You understand? Because little by little the temperature must increase up to this level. At this level it should be 120. So 40 by 40 it is increasing. So at this place it is 0. So the difference is 40. It should be increased because we are going to the direction of increasing. So here the temperature must be 40 centigrade, and here you have to add another 40 to this 40, then you get 80 here. So now after adding this 40 you get 120. That is okay now. So that is the temperatures, the real temperatures at these junctions, but we don't want that those temperatures. What we want is the temperature difference. So here at the denominator we have to write what is the temperature difference for this rod AC, that is 40. 40, this one we have to write. Then you have to simplify, k cancel, then 3 times 220, then 3 into 2 is 2 times 3 equals 6. So that is the answer. So children, this one is the answer. Then you can be happy if you have solved the problem correctly. That means you have understood. So children, I think you are happy because I did even this a target question even. You are happy, don't you? Right. If you are happy, please make me happy also by subscribing my channel. Don't leave the channel without subscribing. So then see you tomorrow. And also I have to tell you, don't subscribe twice, then it will be cancelled. If you haven't subscribed yet, then only you have to subscribe my channel. So thanks very much for those who subscribe my channel and watch my videos again and again. For those who watch my videos, I must thank them also. See you tomorrow at 6 o'clock. Goodbye children.